Hi, this is Andrew. I'm a software engineer and tech lead for Silicon Valley companies like Microsoft, LinkedIn, Snapchat, IBM. I will be your instructor for the course, Software Engineering Interview Prep. If you're targeting software engineering role at top tech companies, I would highly recommend you attend this course. This is absolutely for free, and we will cover everything from product ideation to software engineering to technical interview questions and how to approach the right companies correctly, as well as go-to-market strategy. So during this course, I will cover all the critical topics, most asked interview technical questions, and efficient ways to solve them. I have more than 7 years of experience in software engineering role at top tech companies in the US, and I have helped a lot of candidates with interview preparations. So I'm very, very thrilled to help you land your next dream role. So sign up for my course, and I look forward to meeting you in the upcoming sessions. So let me give you a quick overview of HiCounselor. HiCounselor is an online career accelerator that helps job seekers find full-time job. So HiCounselor helps candidates interview preparations as well as getting the interview calls. So we utilize AI-powered job search algorithm and strong network of 300 plus employers to help candidates land a job. Every candidate gets personalized attention and membership and mentorships from professionals like myself who come from top tech companies in the US. The payment structure at HiCounselor is income share agreement, where you don't have to pay anything until you find a job. So once you land a job, that's when you pay a small fraction of your first year salary in monthly installments. So there's nothing upfront. If you're targeting a role, HiCounselor could be a great resource for you. The next cohort at HiCounselor starts, and if you're interested in, please apply on hicounselor.com. Feel free to use my code Andrew, ANDREW, and you will get a $500 discount when you start paying HiCounselor after landing the job. In this session, we're going to go over some of the medium level technical interview questions that I, as a software engineering candidate in the past, have faced when interviewing for companies like Google, Apple, Microsoft, LinkedIn, Snapchat. So we'll get started right away. So we'll start with a simple question, and we'll do maybe like 4 or 5 altogether. So the first question is, what is the best way to convert binary tree into doubly linked list? This is a very, very common question asked by multiple tech companies in the Silicon Valley area. So the question is, how do you convert binary tree into a doubly linked list? So when we think about it, we can move on to implementation of the above solution. So how do you write a program, let's say Java, to convert a given binary tree into a doubly linked list? Obviously, you're going to have a class given like this. And then our goal is to come up with a solution. Well, first goal is to think about what is the approach, what is the avenue we have to take to solve this before we talk about implementation. So I will give you around 3 or 4 minutes to think about how we should approach, and then we will solve together afterwards. Okay, so I'll give you 3 minutes or 4 minutes. Okay, so we have the class node available to us, and essentially we have left node, right node, as well as the data. So when we have the class, what we need to do is as such. So this root is going to be the root of the binary tree. And then head is the reference of the head node of the created double linked list. And then a simple recursive method needs to be created. Why? Because we need to convert a given binary tree into a doubly linked list. We have to care for the base case. So we check if the root is null, in which case we just return. And then we have to recursively convert the right subtree and then insert the root into the doubly linked list, change the left pointer of the previous head, and then change the head of the doubly linked list, and then work on the left tree. So we start from the right subtree, work on the head, and then go on to the left subtree recursively. We have to change the left pointer of the previous head. So if the head contains something, we change the left pointer of the previous head. And then we say that the head is equal to root because we need to change the head of the doubly linked list. And then because we already finished the right subtree, we also need to convert the left subtree by also calling recursion method on the left side. Binary to doubly linked list. Now, we're done, but optionally, we should still write our utility method for printing the doubly linked list. we could make this package private, but just for simplicity, we'll put package private as oh sorry, we could write it as package private, but for simplicity, we'll just put it as public void print list. And then, of course, we would need the driver program to actually test the above functions. So this part would just be populating the trees with the left-right nodes, writing up all these subtrees, putting in some values in, contents in, elements in, and then calling the binary to doubly linked list, and then actually printing that list. So I won't write that part, but it's mainly divided into three parts: the driver method, the print list, as well as the binary to doubly linked list. Okay. So here's another interesting question. Find the largest Fibonacci subset. That's the question. So we want to be able to get the largest subset of an array whose all elements are Fibonacci numbers. So find the largest subset of an array whose all of the elements are Fibonacci numbers. So I'll give you guys, again, 3 to 4 minutes to think about what's the best approach for getting the largest subset of an array where all the elements inside that are Fibonacci numbers. And then we'll work towards the implementation together. So it's going to be find a Fibonacci subset given an array of integers, and then we just print the largest subset of the array. So in this solution, we need to generate all the Fibonacci numbers until the maximum and then essentially store them. So again, we need to print the largest subset of an array where all the elements inside are Fibonacci numbers, right? So our approach is going to be, we create some Fibonacci list, the result list, and then the maximum. So we generate all the Fibonacci numbers until the maximum, and then we store them. So how is it going to look like in terms of the code? So in here, the maximum is going to be set as the collections, which is the library API. And then we're going to call X, which is the integer array. Oh, let me put the parameters as well. Yeah. So in this section of the code, we're going to make all the Fibonacci integers until the maximum and then store them. So at A, and then we have the driver main method, driver function. Where we're going to declare an integer array. And then we're going to put in some numbers. As such. So what did we do? We said that the maximum is the maximum from the array of integers. And then we made it a list of integers called Fibonacci, as well as a result. We declare A and B to be 1. And then while the value of B is less than the maximum from the array, which is X, we say that C is the sum of the two. And then we update the A to be B, and then we update the B to be C. So we keep increasing that, because remember, C is the A addition of B. So we add the value of C to the Fibonacci, which is a list of integers. And then once the B less than maximum condition is broken, meaning that B is larger than maximum or equal to maximum, we break out of the loop. Then we go into the for loop from the beginning of the array to all the way to the end. And then every iteration, we check if the Fibonacci contains that value, which is X at some index. So for every index of X, all the way from 0 to n minus 1, we check if that value at such index is contained within the Fibonacci list. And if that's the case, we add that element to the result, which is going to be the answer, right? So we keep doing that until we are out of the range, at which point we will system out the print line result. So this is the important part. If the Fibonacci contains our element, we're gonna result add that element, break out of the for loop, and then print that. Okay, so this is another commonly asked questions by across literally all companies that I faced. So here's another question. The question is, how do you write a Java program which returns true or false if there is a Pythagorean triplet in a given array? So we need to return true or false if there's a triplet with the following property, which is so we need to true or false if there's a Pythagorean triplet in a given array. So the method signature is going to be this. Okay, so I'll give you again, 3 to 4 minutes, and then we'll solve the problem together. Find if there's a Pythagorean triplet in a given array, given this structure. Okay, I'll come back. So for this question, we need to, first of all, iterate through the whole thing. And then square the array elements. And then next step, we sort out the array elements, right? Next, we fix one element one by one, and then find the other elements, other two elements. So what does that look like? We start from the back, as long as it's bigger than 2. So to find the other two elements, we need to start two index variables from the two corners of the array and move them towards each other. So what does that look like? We say that left is 0, which is the index of the first element in the array. And then we say that right is I minus 1, which is the index of the last elements in the arrays from 0 to I minus 1, right? So while left is less than right, we know that the triplet is found if this condition holds true. And then else, we either move the left or the right. So yeah, this is the way we do it. We square the array elements, we sort them, and then we go from the end to the beginning, and then we declare the left to be 0, which is the index of the first element in the array from 0 to I minus 1. And then we say that right is I minus 1, where it's the index of the last element in the array from 0 all the way to I minus 1. Because we're going from right to left for the outer for loop. And then while the left is less than right, if the triplet is found, then we return true. Because we're trying to find if there's a Pythagorean triplet in a given array. If that's not the case, we either move to the left or we update the right side. So if the left plus right is less than the I, then we increase the left because we sort it out, and we decrease the right if the left plus right is larger than I, because it's too big. And then if we reach the return false statement, oops. That should be false. Yeah, so if we reach this statement, it means that we know triplet was found thus far. So that's the way you approach this question. All right. So the last question I want to give you all, and then maybe you can try it out as a homework assignment, or just think about it and then come back in the next session. is how do you find the maximum of all subarrays of K? So the hint, how do you find the maximum of all subarrays of K elements, right? And the hint is this: you need to use a self-balancing binary search tree, BST. So the first method, or the first step, is going to be you pick the first K elements and you create a self-balancing BST of size K. And then I'm going to leave the rest of the steps for you to do. So again, the question is, how do you find the maximum of all subarrays of K elements? So this is something for you to think about, and then we'll come back in the next session and solve together. So I want to thank you for your attention and participation, as always. Again, if you need assistance with job search, group coaching, or one-on-one mentorships into how to get into Silicon Valley companies, I could be a great resource for you with HiCounselor. So do check out HiCounselor.com and type in ANDREW or Andrew as a referral code. And the payment structure of HiCounselor is an income share agreement, so you don't have to pay anything up front. So once you land a job with tech companies, which you will definitely, because you're going to have a lot of values from all the instructors at HiCounselor, you're going to pay only a fraction of your first year salary in monthly installments. So there's nothing upfront in terms of upfront payment. The next cohort at HiCounselor starts August. Starts October. So if you're interested, please apply on HiCounselor.com. And feel free to use my code Andrew, ANDREW, and you're going to get a $500 discount when you start paying HiCounselor after landing a job in companies like, startups, or even big tech companies, or even FAANG companies, because I've been there. I've interviewed for all those companies, and I had a lot of rejections. I've had more rejections than acceptance for sure. So we are here for you, and I'm here for you. And I'll see you in the next session.